Hello, welcome to Season 2, Episode 3. We're given the velocity of a moving body. We're given a formula, looks a bit like that one there. 2t cubed take 4t squared plus 3t. And we are asked to find the distance travelled between t is 1 and t is 5. Now, in theory, we could get that from this question, this statement. We're going to integrate in the range of 1 to 5. But we have to be very, very careful here because it asked for distance. Now, distance doesn't matter whether someone's travelling towards you or away from you. We want the total distance travelled, which is subtly different to displacement. The example I used before is if I go from Brisbane to Rockhampton and back, my displacement is 0 because I'm still in the place where I started. But the distance I travelled is about 1,480 kilometres because I did go a long way and come back. Now what that means is that we have to check if there's any point where the velocity is 0. In other words, where they've stopped and possibly gone in another direction. So the first thing we do is set 0 to be equal to the velocity formula and try to solve. There's a common factor of t. I've taken the common factor of t out. Now, to see whether we can factorize that, I started doing a table and it didn't work. Now, I'm going to try and solve that section using the quadratic formula. So you remember that as x equals negative e plus or minus b squared take 4ac over 2a. In this case, a is 2, b is negative 4, c is 3. So if I put those values in the quadratic formula, I'll get 4 plus or minus negative 4 times negative 4 will be 16. Take away 4 times 2 times 3, all over 2 times 2, which is 4. Now, you'll notice in there, I'm going to end up with 16 take away 24. I'll end up with a negative in there, meaning no real solutions to that section. So, essentially, the only x-intercept here, or t, is at x equals 0, meaning t equals 0. Alright, so that's good. That's good news for us because if it had been something like 2, we would have needed to split this and integrate between 1 and 2 and 2 and 5. But since the only intercept is at 0, there is no intercept in that range. We can go ahead and integrate in that range. So let's do that. Integrating in that range. So each time, increase the power by 1, divide by the new power. Here, increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power, with our range of 5 and 1 on the end. That can be cleaned up a bit, 2 on the top, 4 on the bottom. I'll change that. So I'll get t4 over 2, take away 4t cubed over 3, plus 3t squared over 2, between 5 and 1. And now, as per normal definite integral, I'm going to substitute 5 in and take away what I get if I substitute 1 in. So I'm going to get 4 over 2, take 4 times 5 to the power of 3 over 3, plus 3 times 5 squared over 2. Take away what I get if I put 1 in all of that. So it'll be 1 half take away 4 over 3 plus 3 over 2. At this stage, I think I put that in my calculator. So let's do that. We could muck around for a while, but let's not. So, whoops, a new 1. So big brackets, 5 to the power of 4 over 2. Take away 4, I'll put that on the top, 4 times 5 to the power of 3 over 3 plus 3 times 25 over 2, close bracket, and take away everything that's in the brackets here, 1 over 2, take 4 over 3 plus 3 over 2, close the whole lot. it's giving me 548 over 3, which is approximately 100, well, precisely 182.6 recurring. And that, of course, will need to be in meters. There we go. That's how far it travelled between time is 1 and time is 5. You could put that as a sentence.